Hi, welcome back to my channel Reagent. In this video, I'm going to explain about energy profile diagram for the decomposition of calcium carbonate. From chemical thermodynamics, there are two kinds of reactions we discuss. One is endothermic chemical reaction, other one is exothermic chemical reaction. So this is an example, best example for the endothermic chemical reaction. What is endothermic chemical reaction? The chemical reaction in which energy absorbed then the released. Means absorbed energy is greater than the released energy. Hence, so endothermic chemical reaction we say. Endo means inside, exo means outside. Again, I'm repeating endothermic chemical reaction, the chemical reaction in which energy is taken or energy is absorbed for the reaction to happen. Most of the endothermic reactions are non-spontaneous reactions, we say. Look at this graph. So there is, in this graph, so x-axis is represented here and y-axis is represented here. And on y-axis we take potential energy, and on x-axis we take progress of the reaction, we take our reaction pathway, on x-axis. And as let us assume that reactants or calcium carbonate in the form of solid, which is called limestone, reactants having less amount of energy. This amount of energy not sufficient to decompose to form calcium oxide and carbon dioxide. So in order to make reaction happen, in order to make calcium carbonate to decompose to form calcium oxide and carbon dioxide, we have to supply external amount of energy, that is EA, activation energy we say. So that activation energy shown in the arrow mark, delta H equal to plus 572 kilojoules per mole. 1 mole of calcium carbonate for decomposition to produce 1 mole of calcium oxide and carbon dioxide gas. So energy required required is how much? Delta H equal to positive 572 kilojoules per mole. That means here calcium oxide and carbon dioxide are products. These are products and these are reactants. So the energy difference between the products and the reactants is how much? So here we can see plus 572 kilojoules per mole, which is this is said to be endothermic reaction. Endothermic reaction we say, this is means almost all the thermal decomposition reactions are endothermic chemical reactions. So that means here for change of reactants to products, enthalpy change is equal to plus 572 kilojoules per mole, which is said to be endothermic chemical reaction.